Now we're moving into the trigonometry, unit 2, and we're starting off with some of our very basic questions. So for question number 19, if we take a look at our unit circle, okay, and we have, let me make this, oops, light. Okay. And we want to look at the definition of any angle on the unit circle in standard position. First of all, any angle on the unit circle, we'll call it theta. Okay? If you wanted to find the 6 trig functions for theta, you know that if I drop a perpendicular to the x-axis, this is my x-coordinate, this would be my y-coordinate, and this would be the radius of the circle, which in the terms of the unit circle is always 1. And I said, no matter where theta is, it's a central angle, then I can define the 6 trig ratios in the following way. I know that the sine of angle theta, by definition, would be the opposite side, which is y, over the hypotenuse, which in the case of the unit circle is r. And for cosine, it's adjacent over hypotenuse, which would be x over r. And then tangent is opposite over adjacent. And then you have your reciprocal functions. So that makes your 6, group of 6. And that would be cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotan is the reciprocal of tangent. And that gave us our group of 6. All right, question number 20. If you have the sine of some angle as -4/5 and the cosine is greater than 0, what are the values of the other trigonometric functions? Okay, the basic question you want to ask yourself to get started is, if the sine is negative and the cosine is positive, where does my angle terminate? Well, where is sine negative? Sine is negative, below the x-axis. And cosine is positive to the right of the y-axis, first and fourth. So the angle in question terminates in the 4th quadrant. So I want to create a triangle in the 4th quadrant. And using my given information that the sine is 4/5, -4/5, that would be, here's my reference angle. This is the opposite, this is the hypotenuse. This is my y, this is my r. So I know that -4 is here and 5 is here. Now this happens to be, I wouldn't have known this third side. So this happens to be a special right triangle. And if you know the Pythagorean triple 3, 4, 5, you know that this side has to be 3. If you didn't know that, then you would have to actually do the Pythagorean theorem. So we have x squared plus -4 squared equals 5 squared. And then of course you get x squared plus 16 equals 25, x squared equals 9, and x could equal plus or minus 3. But now you have to pick the appropriate sign depending on the problem. And since we're to the right of the y-axis, this x has to be 3, so -3 doesn't make sense in this situation. Once you have your sides, then you can just use the definition of the 6 trig functions that we have here and come up with the appropriate values. So for example, cosine is adjacent over hypotenuse. In this case, adjacent is 3, hypotenuse is 5. And then secant's the reciprocal of that. So I just reciprocate or flip the fraction. And then cosecant is the reciprocal of sine. So I already had that, so I just flipped it. and then tangent is opposite over adjacent, which is negative 4/3, and for cotangent it's the reciprocal, so I flipped it. And finally, one of the skills that you have to have in order to answer a lot of the questions we have done in trig is to determine in which quadrant a particular angle lies. And this is more of what I did up here. If I know the sine is positive and the tangent is negative, then I have to determine by a little checklist. I know sine is positive here and here, first and second. I know tangent is negative in second and fourth. So there's a mistake here. First and second, second and fourth. This should be in the fourth. Oops, let me fix this, guys. Second and fourth. So negative here, positive for sine here and here, positive for sine here and here. So it's the second quadrant in which both of these conditions hold true. All right, B. I know cosine is negative to the left of the y-axis, so second and third. I know tangent is positive first and third, so I did a check of those. So I had first and third for the tangent being positive, and second and third for the cosine being negative, which means I ended up in the third quadrant for both. And then I said that these two hold true in the third quadrant. Let's see how that worked out. Okay. First of all, secant is the reciprocal of cosine. So if secant's negative, cosine's negative. Cosine's negative in the second and the third. So negative here and here. And then cosecant was negative, which means sine's negative, and sine's negative in the third and fourth. So both conditions held true in the third.